Eze. I'm really privileged to start my keynote here. Thank you for this invitation, and my sincere thanks and really warm regards to your president, Dr. Kabir. He's my very good friend. And moving on, my presentation will focus on what are some of the protective systems in earthquake engineering. It will be more focused on structural engineering, and I'll focus on some of the things that I did before in several institutions, and then I'll move on to what are the things that I'm planning to do now in Nepal. So this might be an interesting one for some of the new engineers that are planning to do their work, PhD students who are doing their work in Japan, and maybe how they can career path, because Professor Sudin, I think Professor Sudit, he had a really good presentation on what kind of career paths that a student can have, and how they can go ahead with their publications, everything. He covered quite a lot on that aspect. My focus will be more closer to what Dr. Maheshwar said, some of the research works that can be done. And I think Dr. Maheshwar, he has quite a lot of experience of working in Nepal. So my experience in Nepal is a bit short. I'll just go through my biography and then I'll tell you what I have done until now. I did my undergrad and master's, as said by Pradeep sir, in TU, IOE Pulchowk campus, MSc Structural Engineering there, and IOE BE in Civil Engineering. Then I moved to Kyoto University. I was there for almost 6 years. I did my PhD and I did my postdoc as well there. I stayed with my professor for almost 3 years, doing postdocs and extending what I did during my PhD. During that time, I was able to get a research grant to work as a research associate at University of Nevada, Reno. There, my work was more focused on what I did in my PhD and tried to do some collaborative work with the professor in Nevada. Then I moved to Qatar University. It was really one of the best experience of my life working in university. I had quite a lot of freedom there. I had a lot of financial backings that I could do, and a lot of research work I did in Qatar University, establishing the university and doing a lot of research works there. Then finally, I was able to work as a full-time faculty in Nagoya City University. That was a great opportunity that I had as an assistant professor. I worked there for almost 3 years in well-renowned projects and grants that the university got, and I spent a good time, almost 3 years there. And finally, what I dreamed of, I dreamed of getting back to IOE. I dreamed of getting back to where I came from, my alma mater, and I was able to get it as a fast track openings that TU had. And I didn't miss that opportunity. I came back to IOE. I applied for it, and then I was lucky enough that I was selected there as an associate professor in fast track. Usually, as you may know, at IOE, it takes a long time to get into associate professor level, but this was a one-time ADB funded fast track opportunity that they give to young researchers who are more research oriented in their work. I'll share more of my experiences, international research field, for almost 2 years that I had from 2007 till 2020. Then that could be a motivation to young engineers, researchers who are, I think a lot of participants here are from that background. And I'll just move into some of the works that I'm doing in Nepal for the last 1 year. I'm here from last 1 year, 1.5 years. So some of the things I'll move into what I'm planning to do, what I'm now getting while I'm in Nepal, and that could be also one of the motivations to get some of you back to Nepal to work in Nepal. Okay. If anyone is interested in shape memory alloys, anyone knows, because I'm moving on to some of the research that I did in Japan. and some of the scopes that I found in Japan in high performance materials. If in chat, simply in chat, if some of you know about shape memory alloys, or maybe Professor Sujit knows because he's from mechanical engineering, so he might know about these shape memory alloys or superelastic SMA. Anyone in chat? Okay, maybe it's a little bit. I cannot see the chat here, Pradeep sir. I think okay, I'll move back. Okay, shape memory alloys. These are special alloys. They have memory of the shapes. So what are these? I'm just trying to show you what these materials are. As it is said by its name, it remembers its shape. So if you deform this material beyond this plastic limit, so you are going beyond its elastic limit, right? But the material, after it is deformed beyond its plastic limit, if you get some heat to that material, it has got property of getting back to its shape. So this is what I was working on during my PhD as well as postdoc for almost 8 years. The material which remembers its shape. Anyway, this is shape memory alloy, but in civil engineering, structural engineering field, it may not be quite easy to control the temperature of the material inside the building. So what I was working on was superelastic shape memory alloys. They do not need heat. They get deformed and come back to their original shape within the room temperature. So this is the material that I was working on, superelastic shape memory alloys. And maybe you might know now how this application was used in the research field that I was involved in for almost 8 years. In conventional steel reinforcement, there will be quite a lot of rifts. If you could see, the buildings could not be repaired. They cannot be reused. My focus was to reuse those structures, and that could be achieved with the use of these innovative superelastic alloys, shape memory alloys. And my you could say my luck, my professor was in collaboration with Tokyo University material scientists. They were developing these alloys. They were very new. They weren't commercialized yet, and I could use them directly in my research. And that helped me in my PhD to get publications. So this is just a stress strain curve, and engineering student understand this. For steel, there is residual strain, and for superelastic shape memory alloys, they return back to their original shape. So that is the difference that I was looking for. I used that for my PhD in masonry structures because this was relatively very new material in research field. I was able to publish quite a lot of papers on that. So in that sense, I was very lucky to be involved in such a project, innovative project. This is just an example of what happened when I used it in masonry structures. You might need to turn your volume a little bit low. It's a bit, for steel reinforced masonry, as I showed you in one of the pictures, the structure has a lot of residual drift. You may not be able to reuse the structure. You might have to demolish the structure. But when we use these innovative materials inside our civil engineering structures, this is steel for a certain level of excitation. But when we use the material for almost twice the level of excitation, we were able to achieve that shape memory effect. The structure could come back to its original position, and you could reuse the structure quite easily with very minor repairs. So that was my primary goal of my research. After my PhD, with the application of masonry, my professor told me, why don't you stay here, do a postdoc why don't we apply this to steel structures? Why don't we? So I stayed in Kyoto University. We used that application in tension brace members. We did full-scale tests on steel structures. And the opportunity that I got when I could go to University of Nevada, Reno through a research grant. I was there for almost 1.5 years. And the professor there, he was using the same material through collaborative work in bridge piers. So if you can see, these are bridge piers, and in plastic hinges, we use the same materials there. One PhD student there, he was more focused on experimental work. While I stayed there, I was more focused on modeling part, numerical modeling part. So this was application in reinforced concrete structures. So this is another example where we also worked on healing of the concrete. I'll just skip since we are quite late on our work. So this is the bridge that I worked on. It's 1/4 scale. It's not a full scale one, but still it's quite long. This is one of kind of facility. It's in Nevada, Reno, and they have a series of shaking tables that can simulate earthquakes to represent such behavior. As I said, I was more involved in numerical modeling. So I spent 1.5 years to understand one software, OpenSeas, which is quite popular in US in structural engineering field. I was able to use that to simulate the behavior of the structure when using these super elastic safe memory alloys. And when you don't use those alloys, you will have quite a lot of damage in the structures when we use conventional methods. Then after that, I got good opportunity to work in Nagoya City University. I was there for almost 3 years. Yeah, almost 3 years, and as a faculty. And there I was again moved back to masonry structures, which is quite important for Nepal as well. There was a big project, SATREPS project, Zyka funded SATREPS project, and we set up a big laboratory in Bhutan. This is a big project that they started in Bhutan, where they made the whole test facility where they could test masonry structures, the full scale ones in Bhutan. While I was there, I was able to get involved starting from the installation of shaking table tests. We did quite a lot of tests in Bhutan for almost 3 years. And also we did full-scale tests in the buildings. So what I'm still working on is these projects where we do full-scale tests on the buildings. And the main goal is to prepare building codes on masonry, which is more specific, more locally specific to Bhutan and its residents. Since in Bhutan, they are quite conscious about saving their culture. So they want to preserve their ancient architecture, and they are working on developing building codes for such buildings which are already there. They want to save those buildings so that they could use those structures for future and their future generations as well. That is the main goal. I was also involved in numerical modeling part, and this is one of the results of what I was able to achieve through those 3 years of my work. We were able to propose some sustainable, effective retrofitting techniques and new construction techniques for Bhutan. Those were some of the examples that I wanted to share while I was working as I was from IOE. I did my master's. But after my PhD and postdoc and as a faculty, I was involved in many big projects, and you will have quite a lot of opportunities in Japan, elsewhere, to work in a lot of projects. So you shouldn't limit yourself. You should see around, and you can get involved in quite a lot of big projects, which are very important. So you shouldn't keep yourself within yourself. You should explore more while doing your research during your PhD and even after postdocs. The opportunity will always come to you. And these are some of the research works that I am currently involved in. I've been in in Pulchowk campus for around 1.5 years, and then I haven't done quite a lot of work, but still I was able to get some projects. And the number one project that I got, this is more of my undergrad students' hard work. I think BK's already presented this work. I'm sorry, I couldn't attend that presentation, BK's presentation, because as you know, I'm just telling you because I really miss one thing from Japan. We did have 2 days of weekends in Japan, but in Nepal, we only have 1 day of Saturday. So it's difficult to manage time in Nepal for Saturdays also. So I was involved in some family work, so I couldn't join for BK's presentation. Anyway, I do miss Saturday and Sundays of Japan. We could spend quite a lot of time with families in Japan, but still, I got one good grant through the hard work of my students and grad students who are working on pounding effects, and we are taking a pilot site in Kathmandu. I think some of my students are still here during this presentation. I thank them for their hard work on this. They are working on it right now as well. It just started, and there's also other 3 running projects that I'm working on as a main primary investigator. As Dr. Maestro said, the idea is changing in Nepal as well. They want to involve research in the departmental work as well in government sector. So there are quite a lot of opportunities when you come to Nepal, when you are associated with good academic institutions, and if you have a good research background, you do have quite a lot of opportunities here. Within the last 1.5 years, I am getting quite a lot of opportunities to work within my university. I don't need to go for consulting work. I can work within the university, and I can get involved in research works and get good funding, sustainable funding for the university as well. That can make you feel better when you are working here. So these are some of the opportunities that I've already got. There are some in the pipeline as well, and I do see good future as Dr. Maestro said. I do see quite a good future for universities and the collaborative work with the government agencies. And I think Dr. Maestro, he's already working with the water resources department of our civil engineering department, and I'm more working with Department of Road and also water supply and sewerage system department with overhead tanks design. With this, I would like to end my presentation. I would say Subhaya, he this is Kabir Sensei's, because Kabir Sensei, he was my sensei for Ranjana Lipi, maybe I think 20 years back. I'm just going back through the memory lanes. He was my classmate during my undergrad, but he also taught me Ranjana Lipi, Subhaya, the 4th one. This is what I learned from Dr. Kabir. Thank you very much for your time. Now move on to what Pradeep sir